Okay, so I'm trying to figure out, I got quotes on windows today. I found the sizes that I need. I found the window that I need. I found a good price that I'm happy with. I'm trying to decide, do I want to build my front face with vertical windows like this, and then some overhanging windows at like a 45 degree up here, like the very newest Earthships are being built, or do I want to go with this traditional design of a angled window here? Now, I have to have some angle at some point because this is going to be a summer greenhouse as well. So I need some sun penetration like this in the summer, that'll hit the greenhouse, that'll hit the planter. The planter is going to run right in front here, and it's going to be about 3 feet wide, and that's going to be the primary planter. So I need some sunlight to hit that. I can't just have all vertical windows. This is not just for living quarters, it's for growing plants as well. So I think I'm going to go ahead and settle on this. And the reason, there's a couple reasons, and I'll get into those, but this is about 65 degrees. I've just kind of mocked this up to where the edge of that goes up and just about touches that top edge of that plate. And so that angle will be like this. The windows are 76 inches tall. This is a standard, they call it a patio replacement window. It's double paned. It's about 1 inch thick, and they are non-low E, and they are clear, and they are tempered. So they should be hail resistant. That's the only thing I worry about, because we do get a little hail once in a while. And so, but the price I'm happy with, so we're going to go ahead and plan on those. They're 76 inches tall. My worry was that the angle of the sun in the highest, it is the summer solstice and the winter solstice. What are those angles going to look like inside of here? So I'm trying to extrapolate that. So this is a 79-inch board. My glass panels will be 76 inches tall, so I'm basically allowing for 1.5 inch plate there and 1.5 inch plate there. That screw is about 1.5 inch down. So that's going to be the top edge of the glass right there. Okay, so what I've done was I've just ran a string back here and tied it to the wall, put a screw in the tire bale. And then I took my handy dandy angle finder. This is from Harbor Freight. It's about $5. Use this for tons of stuff. My buddy turned me onto this, and he used it to set pinion angles on vehicles and all kinds of stuff. It's just a cheap angle finder, and I've used it for construction and to set pinion angles as well on my Jeep. And so I'm using it today. It's rudimentary. It's not, it's not super accurate, and I'm not looking for perfect accuracy. This is not precision instrument by any means, but all I want to know is approximates to make sure I'm going to get sun exposure here in the winter, that it'll warm my thermal mass in the back, and also minimal thermal mass exposure in the summer, so that the thermal mass won't be warming in the summer. It'll just be shining on the plants here. Okay, so how I'm doing that, I just ran the string back, set the angle finder on top of it, and let's see what this one is. Okay, and that says it's about 30 degrees right there. Okay, so the lowest the sun's going to go in the sky down here will mean the most penetration to the back wall. So what I did was I used an app. Let me bring this up here. Let me find it here. SolarElectricityHandbook.com. Okay, so what that did was it brings up a solar angle calculator, and you can set your country, your state, and then your city for your latitude. And we're roughly Pueblo, Colorado, so that's close enough to us. And then it gives you all these numbers, and I took a screenshot of it here. Let me bring that up. So here's my screenshot. Let me expand it here. So you can see at my house, roughly, the lowest angle the sun's going to be in the sky is 28 degrees in December. The highest is going to be summer solstice, of course, June 21st, 76 degrees. That's how high it's going to be in the summer. So I just tried to see what those numbers look like. In real life, if I use these 76-inch panes, the top edge of the glass is going to be right there. That means that's about 30 degrees. It's close enough to 28. So in the winter, that's about as high as that sun's going to penetrate right there. So that's about little more than halfway up my thermal mass back here. Of course, we're going to have concrete floor, flagstone floor, probably 4-inch thick concrete and flagstone in it. So that's going to be a good thermal mass as well. This dirt's going to be all insulated. And in reality, a regular earthship, if you stay in a real earthship, the sun never actually hits the back wall of the building, of the actual living quarters itself. It hits the floor, but it never actually hits the back wall, even in the dead of winter. So that's okay. It's still very, I mean, they still work. And this still becomes a thermal battery. So I'm going to have some sun exposure on this as well as the floor. This is a small room. This is not any big size earthship room. So I'm a little worried it'll be overheated. It'll be overdone, but we can always open windows and keep it moderated. So that's going to be kind of the winter solstice right there. That's as high as the sun's going to hit. As the spring comes and the summer comes, it's going to go down and down and down and down. The summer solstice is right here. June is going to be right there, this line right here. Okay, so if my planter's about 3 feet wide, the summer sun that's going to shine through this angled window is going to hit right about there. Okay, so that's about 76 degrees. I took the string, I ran it down there, I held the angle finder on it, did it 2 or 3 times for repeatability. Now, right now, we're about 60 degrees in August. This is a little late August, so that's 60 degrees, that line right there. So you can see summer's starting to wear off. We're starting to head into fall. It's going to start hitting the thermal mass a little bit. It's really only getting down to the 40s at night, so it's not very cold. All right, so that's how I'm figuring this. Also, I got the 60 degrees from this right here. The sun right now is shining, of course, up there, hitting my plate here and making a shadow right there. So what does that come out to? And it's about 65 degrees when I put the angle finder on. I can't do it with 3 hands, but I put the string right there on the ground, put the angle finder on it, and that's about 65 degrees. So 60, 65 degrees, that's about what we're getting right now, about what the book says, or about what the website said. Good. Now, so that's going to be the coldest part of the year, right? It's going to be, that's where the sun's going to be hitting right there. But what about average winter? So what I did was I averaged the 6 months of the coldest times of the year: October, November, December, January, February, March. That's the angle of the sun. So 44 degrees in October, 28 in December, 52 in March. So I averaged those. If I take a 6 number average, 6 of those, that's 240 divided by 6, that's 40 degrees on average. If I average the very coldest months, the 4 coldest months, that's 1, 2, 3, 4, November, December, January, February, that's 144 divided by 4, it's 36 degrees on average. Okay, so this is about 30, this is about 40 right here. So the sun's still going to be hitting between here and here, between, you know, November and February. It's still going to be hitting right here. So it's still about the midpoint of my thermal mass. I don't know if that's good or bad or accurate, or, I mean, it's somewhat accurate, but I don't know if it's good or bad or going to be too much or too little. We'll still have cooling tubes. We're still going to put in automatic vents that open at a certain temperature and close at a certain temperature. That's going to be a little bit of investment, but I think that's going to be worthwhile for keeping the temperature moderated. If it gets overheated in the winter or underheated, they'll close automatically. So if we have a cloudy day, they'll close automatically. Keep it warm. That's the plan. So that's how I'm finding my angles. Like I said, it's rudimentary. It's not exact science by any means, but it gives me a good idea. And this is a big experiment. I can't find any real science on building with tire bales, so this is all a big experiment. So we'll see how it works out. We'll know for sure by next spring if it's going to be too much or too little. Okay. Oh, and last thing, I am going to settle on the angled windows because of cost, and also because I think it's going to be enough, and materials as well, not just cost in glass, but cost in wood framing. This is going to be much simpler wood frame, just to go from here to here, rather than coming up and then building 45 degrees and all the supports that they'll need in between all the way across. And then what that would mean is I would have some vertical panes along here, vertical panes, dun, 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 and then I would have to buy 4 more panes to go across the top long ways, 76, 76, 76, 76. And so that would be another $1,000, which would be fine. And really, those are the only ones that really need to be tempered. These vertical front ones shouldn't really need to be tempered. So I could save some money. So it might come out to be close to the same if I did that. I would spend a little more in wood. And I think I'm going to have obviously you can have leakage problems from the water settling down here in this little trough. That's going to happen right here, but the same thing's going to happen if I have a 45-degree angle up here. It's going to settle up there as well before it hits the vertical part. So I'm going to either have it up there or I'm going to have it down here. So I think I'm just going to go ahead and go with these angled windows like this. I'm going to have some angled windows to some degree to let sun penetrate and hit the planter right here that's going to run right here. So I'm just kind of stuck one way or the other. If this was just a dwelling, if this was just for thermal mass for a dwelling, and we wanted to stay cool in the summer and heated in the winter, then vertical panes by all means, nothing overhanging, and it should work perfect then. Okay, good. Got to use the table saw finally. So here's 2x6x10. So this is just going to be just high enough for my window boxes. And what I did was rabbited these joints out, okay, and put some glue in the middle and lined them up, and then ran 2.5-inch drywall screws or decking screws down the middle. And so they should be fairly straight. They shouldn't warp too much. That's my hope anyway. I was hoping to find a dado blade. I just haven't bought one, honestly. And so what I ended up doing was just using the regular saw blade, setting it 1 inch out and 1 inch deep. Okay, so that'll be deep enough for these windows. That rabbet joint there will be deep enough for these 1-inch windows. Now these are the 1-inch windows I think that Mike Reynolds is talking about in one of his old books. My local store calls them patio replacement windows. They come in standard sizes. So this is 2 of them. This is the only 2 they had in stock. I had to order some more. They are 1 inch thick. So they're 1 inch. And they're double paned, of course. This is not low E glass. This is regular glass that will let the UV light through. And it's also tempered though. So these were $2.50 a piece. These are 34 inches wide and I think 76 inches tall. Yeah, 76 inches tall, 34 inches wide. So I ordered some 76 inch tall by 46 inch wide. I'm going to need, I think, 5 of those. And so with 7 windows, I should be able to cover the front of the greenhouse. Okay, so I'm pretty happy at this price. I thought I was going to have to spend a whole lot more. Now these standard size are standard size. That's why they cost what they cost. The 46s I think are $275, and these are $250, these 34s. So maybe that sounds expensive. To me it sounds really cheap, because when I had priced custom cut tempered double pane glass, it was going to be like $1,000 a pane or something to get them custom made. So these are pre-produced. This is what they produce all the time. That's why they run about $250 a pane. So this should be pretty good for angled glass. I'm pretty happy. And so I've got a couple more of my laminated pieces here. And you can see my angles aren't perfect here, but I can square those up with the belt sander or the saw. That one's actually pretty good. So 25 degrees on the bottom. I'm cutting a 65-degree angle on the top, and that should put my windows at 65 degrees off vertical. So, or 65 degrees, what am I trying to say? 65 degrees off horizontal. Okay, so good. And I'm going to roll these over to the greenhouse. I'm going to try to put a couple in place. Squaring them up is going to be kind of a pain in the butt for me, because that is not my forte. And but I'm going to take my time and get it right. And then I'm going to set a window in and just see how it looks, and make sure it all lines up and it looks square. And then I'll go ahead and anchor these in and go ahead and silicone around, put a window in, and then probably just screw some blocks on the outside just to hold it in place till the silicone dries, and to hold it in place until I can get the front fascia on. And so we'll start with one, and we'll go from there. Hopefully my other windows will be in next week, and I'll be able to work my way across. I'm going to put a 34 in, 46, 46, 46, 46, 46, and then another 34. And that'll take up the whole front, 26 feet of my whole front of the greenhouse. Okay, good. I made some progress today. Got one window in, and It actually went pretty well. I was surprised. I thought a lot of this would be a lot harder. I thought it'd be hard to rabbet these joints for the windows. It was super easy with the table saw. I thought it'd be hard to get the windows square, and it wasn't. It was super easy. I just squared this leg with the bottom and then tacked it up there, squared this leg with the bottom, tacked it up there, made sure these measurements equal those measurements halfway and at the top. This one was a little bit bowed, just like a 1/4 inch out, so I put some pressure on that, just put some rebar in the ground and pushed down on it, and then put a screw in it to hold it where it's in line. Then I tied it together with this board behind the glass here just to hold it in place, and hopefully that'll cure like that. I'll leave that for a couple weeks probably, maybe longer. And then I went ahead and put a couple screws at the top there, 4-inch screws. This turned out to be the easy part. I was surprised because these wedges that I cut out from these pieces right here, those wedges were the perfect angle that I needed. So I just put them under there and squared that up against the bottom of the window, or squared it up as best I could, put some screws in, and then when I put the window in, it was sitting sideways a little bit like this. So I just raised this side up so it was square. It had a 1/4 inch on each side at the top and a 1/4 inch on each side at the bottom. And then I put screws in those to hold them in place. So that's supporting the bottom of the window. And then silicone along the edges. And then I went ahead and rabbeted a 2x4 right there along the top edge, and then put some 1/4 inch rubber spacers just like we have here at the bottom on the top, and then set that in, and then put screws in from the side. So that's all tying it together. So these boards here are tied together at the bottom, in the middle, and at the top. And it's going to be a while before I'll be comfortable enough to pull this board off right here. In fact, I may end up framing it in on this side just to tie it all together, and then I'll pull that board off. So the only thing I wished I'd done differently was tried to cut these where there would be more heavy wood contacting the top. But it's 7.5 inches of that, and that's basically a 2x4 that's touching it. This is a 2x6, of course, but that's about 4 inches of board up there. That's got contact, so, and it's 2 boards wide. So it's 3 inches wide there. It's 3 inches wide there. So, and this glass is not heavy. I can lift it by myself. I was really surprised. This is a 34-inch pane, so the 46-inch panes I'm sure are going to be a little bit heavier, but okay, good. So this bottom board is not only screwed through there and there and there into that plate, but through the sides here. Those go into this board right here. This one just toenails into that. I've got another 4-inch screw going from here into there, and as well as on that side. So I feel pretty comfortable about the way it's tied in at the bottom. I may put some reinforcing brackets out of steel right here in these corners just to give it some more tie into this bottom plate. But and then the last thing I'm going to do, just for my own comfort, is to take some like 3 or 4-inch lag screws and put them in from the back of this 2x4 plate, or sorry, the 2x10 that goes along the front, put them through that into the back of these, like that. So I'll have to dig through the garage and find some of those and put those in the morning. Okay, good. I'm pretty happy. I had a hard time finding window details of how people were building these. And so this isn't necessarily how anybody else has built them. This is just what I could get out of Mike Reynolds' books and talking to the guy I bought the glass from here in town. And when I mentioned Earthship glass to him, this is what I'm trying to do. He's like, oh yeah, let me come show you. This is what I got. This is what they use. And he actually used some of this glass on the side of his shop to, he has several of these panels along the side of the shop with black painted along the back, and then a fan circulating air through, which just kind of helps moderate the temperature of his shop in the wintertime. The sun warms that, and then it just kind of circulates real slowly just to help keep the cooling or the heating bill down in the winter. So yeah, so 1 inch thick, 34 inches wide, 76 inches tall, non-low E, and tempered. So I'm pretty happy. Then my wife just asked me, what are we going to put across the top? This will just be wood that goes across the top. We'll just end up putting wood across the top, and then probably metal, obviously, and then that's where we're going to bolt solar panels probably, if we're going to have anything like circulating fans, or maybe we'll put some solar panels and a couple batteries if we find that we need to do that. Okay, good.